If we talk about various materials, especially for flanges, okay, there is a wide range of materials available. For example, the carbon steel, low temperature carbon steel, alloy steel, stainless steel, cast steel, plastic. Okay, there are so many materials which are available. Okay, but in case of oil and gas refinery or any process plant, these are commonly categorized into carbon steel, low temperature, stainless, and alloy. Okay, these are the flanges which are commonly used. Also, if we look on the relevant standards of these materials, for carbon steel, ASTM A105, ASTM 350 is for low temperature carbon steel, ASTM 182 is for alloy and stainless steel. These three ASTM standards belongs to forged category, forged flange, okay, forged material you can say, and we can use these three ASTM standards. If we go through these A3M ASTM standards, then we'll come to know all the requirement, at least material requirements with respect to flange, or you can say the forged flange. If you look at why we are talking about forged flanges only, in piping system there will be a lot of components along with pipe, but flange joints are something which are the weakest point, as these are considered as the leakage source. So we don't want to go with any other type of construction, we go for forged only, because we compare, if we compare all these with other casting or wrought type uh, flanges or materials or fitting, then you'll come to know that forging are the most forging fittings or flanges will be having most strength as compared to other, comparatively most these will be stronger. So we only go for forged flanges in process industry. So we'll talk about these three ASTM standards so that we can understand what are the basic requirements with respect to material. ASTM A105. This is for carbon steel forging materials. Okay. So what we are going to cover in this section, we have divided this whole ASTM clauses into few categories. First, we'll look into scope and inclusions, exclusions also, heat treatment requirements, journal requirements, chemical and mechanical properties, ordering information, hydrotest requirements, surface finish, appearance, corrosion protection, identification marking, test reports, and product marking. These are the headers which we are going to discuss. There are many clauses where we have to refer to some other ASTM standards. So those things will also be discussed here. So let us start with the session and let's start with scope and inclusions. So let us talk about the scope and inclusions along with the exclusions for ASTM A105. So if you look at the title, it is talking about the standard specification for carbon steel forging for piping application. Okay, carbon steel forging. Okay, that means what we are trying to say, this standard is applicable for flanges, fittings, valves, and other parts which are specified by the purchaser. Okay, and these are the forged carbon steel category. So this can be flange, forged fittings, forged valves. Then this standard can be used. At the same time, when we are talking about forged fittings or flanges, these are more stronger as compared to cast and wrought. So these can have high temperature and pressure services. At the same time, if you look at the limit of maximum weight, that is 4540 is there for ASTM A105. If the weight of the particular item, whether it is valve, fitting or flange, if it is more than 4540 kg, then we have to go for ASTM 266. That is for carbon steel forging pressure vessel components. Okay, so this is something which we need to remember. There is a limit of 4540 kg with respect to weight, then we cannot use this standard for those particular fittings. Then there are few exclusions also. If you see, it does not include tube sheets and hollow cylinder forging for pressure vessel shells. This is number one. Second, it does not talk about the raw materials by which these products are formed. So these two exclusions are there for ASTM A105. Now, with respect to heat treatment requirements for carbon steel forging, there are few guidelines which says heat treatment requirement is not mandatory, okay, except for the following. Now, with respect to class rating, okay, we have three requirements here. If the flanges are there and these are above class rating 300, then we have to go for heat treatment. Okay. When we are talking about the special designed flanges, then again there is a criteria. If PT rating is more than 300 class, then it is required. We have to go for heat treatment. If specially designed flanges are there where PT rating is not known, then also we have to go for heat treatment. Okay. Piping component other than flanges meeting the following criteria. If we line size is more than 4 inch and class rating is more than 300, then we have to go for heat treatment. Now, if heat treatment is required, then we have to refer all the basic requirements, common requirements, ASTM A961. Okay, so first of all, heat treatment is not required except for these cases. For 300 class and above flanges, it is required. PT rating where special design flanges are there, PT rating more than 300, then it is required. When PT rating is not known for specially designed flanges, then it is required. And if it is more than 4 inch and above class 300, then again heat treatment is required. If required, we have to refer this. Now ASTM A105 shall fulfill the requirement of this. In case of any conflict, then we have to go for ASTM 105. Okay, if you find similar clauses or something which is mentioned in both the standards, then whatever guidelines are there in A105 will prevail. Okay, so we'll look into all the common requirements which are mentioned in A96 in the end. First, we'll discuss the basic product specification first. Chemical composition of ASTM A105 material. It is one of those ASTM standards where there are no grades. So as compared to other material standards, this is at least easy to understand, very simple to understand. We have the list of components, elements, carbon, manganese, phosphorus, sulfur, silicon, copper, nickel. So these are again mentioned here along with the composition. Okay. So this is easier to understand as compared to other ASTM standards. Carbon equivalent, if you say the maximum which is permissible is 0.47, but whatever final equivalent is there between which is decided between purchaser and supplier, that has to be considered. Again, lead is not permissible as per this specification. Okay, so again this is the chemical composition which is there in the standard. At the same time, the chemical analysis report has to be submitted by the manufacturer so that it is ensured that this composition is there for the particular items. If we look at the mechanical properties of ASTM A105, there is tensile strength, yield strength, the basic things. The hardness is also there. So it is very easy to remember for at least this ASTM standard where there are no grades. So if you look at the tensile strength, 70 is the minimum KSI, 36 is the yield strength, and hardness is 197. Okay. So this is easy as compared to other standard to remember all these figures. So mechanical properties along with chemical composition which we just discussed, if we understand this, it is very easy to understand the property of a particular ASTM standard. If we talk about all the ordering information, hydrostatic test requirements, surface finish, appearance, corrosion protection, and identification marking, there are standard guidelines which are given in detail if you refer ASTM 961, which we are going to discuss in a separate session, but all these requirements are captured there. So we can always refer to these specification for common requirements with respect to these four topics. With respect to test reports, there will be many tests which shall be conducted during the course of time during manufacturing or maybe after that. Then those reports shall be generated at that particular time. So these may be provided by the manufacturer at different time periods. So let us see what kind of reports these will be. Heat treatment, what kind of heat treatment processes we have followed. Tensile property results, what kind of mechanical properties this material is going to perform. Chemical analysis result, what kind of composition is there. Hardness test results, any other test required. So whatever test in addition to these, if identified by the purchaser in the purchase order, then those shall also be performed and the report will be provided. Product marking. In addition to the requirement of 961, which are common for many ASTM standards, we have to look into few specific requirements, especially for product marking. For example, if it is quenched and tempered, QT shall be marked. If it is normalized, then N has to be marked. For annealing, A has to be marked. Normalized and tempered, NT has to be marked. So with respect to heat treatment, we have to mark these digits, these alphabets. Then if it is repaired, then W has to be marked. As per ASME 16.11, we don't have to mark anything for plugs and bushes. Okay, and marking shall be painted, stenciled, stamped on the metal or plastic tag which is securely attached to the fitting. Okay, the main purpose of marking is always to identify it at site. So these can be used painted, stenciled, stamped, or maybe a plastic tag so that we can easily identify. Sometimes the barcode requirement is there from client side. So once it is there, then this is also unacceptable for identification. So this is also there in marking. So these are few of the requirements which we really need to understand when we are looking for product marking and all. So let us see how we are going to cover ASTM 350. This is for low temperature carbon steel and for forged fitting. And there is a requirement of notch toughness testing. So let us see what various topics we are going to cover in this part. Scope and inclusion along with exclusions, what is covered and what is not covered, that we'll discuss. Then heat requirements, heat treatment requirements, chemical and mechanical properties, impact testing requirement, hardness test, hydrostatic test requirement, workship finish and appearance, rework, retreatment, certification and product marking. All these topics shall be covered along with additional requirement. If any other ASTM standard we have to follow, we'll at least come to know which standard we are going to follow for that particular thing. So let us start with this topic and let us start with the scope and inclusions. Let us talk about the scope and inclusions of ASTM 350. This is for carbon and low alloy steel forging fittings where notch toughness testing is required. Okay, so primarily it is for carbon and low alloy steels for low temperature services. Okay, where notch toughness testing is a mandatory requirement. So this standard is available applicable for flanges, fittings, valves, and other parts as specified by the purchaser. Okay, so we are saying this 350 is used for carbon and low alloy steels. Notch testing is required and is applicable for low temperature services. Now we have few grades for LF1, 2, 3, 5, 6, 9 and 787. So these grades are covered in this standard. Now there is one exclusion here. This standard does not cover the raw materials by which these products are formed, whether these are flanges, fittings, or valves or other parts. We are not covering the raw material. Okay. So this is the overall scope of this standard. Now this ASTM 350 standard talks about heat treatment requirements. Okay, as we know there are few grades which are there in 350. All the grades except for LF 787 shall be furnished as normalized tempered, quenched and tempered. So there are few criteria which are clearly defined for all the grades where the normalized is done, normalized and tempering is done, quenching and tempering is done. So we need to know what we are going to do when we are going for normalizing. First we are heating it to produce an austenitic structure. Then we are holding at that temperature for sufficient time and we are allowing it to cool in still air. At the same time, when we are talking about normalizing and tempering, we are going to reheat the item up to certain temperature and then hold at that temperature for 30 minutes. Then we allow it to cool in still air. So that is normalizing and tempering. Again, there is quenching and tempering. Quenching can be done by fully ostenizing the forging and then quenching in a suitable liquid media, or fully ostenizing the forging and rapidly cooled, then reheat the partial austenized followed by quenching in a suitable liquid media. So there are few processes which we need to follow. All quenched forging shall be tempered by reheating it to 1100. So this is really important clause. When we are normalizing, then maybe we are doing tempering also, but in case of quenching we have to go for tempering. We have to reheat up to 1100 degree Fahrenheit. We have to hold it at the temperature, then we'll cool it in still air. So quenching and tempering goes parallelly. Normalizing and tempering are both are available for different cases. In previous slide we talked about all the grades except for grade LF787. So let us talk about this. Grade LF787 forging shall be furnished in either normalized end precipitation or quenched end precipitation heat treatment conditions. So let us try to understand both normalized and precipitation, quenched and precipitation. So the only difference here is we have to heat up to certain temperature, we have to hold it for 30 minutes, we have to remove it from the furnace and cool it in the air. This is normalized. Precipitation, we have to reheat up to certain temperature, we have to hold it up to 30 minutes and then we have to cool it at convenient rate. So this is normalized and precipitation. Now let us talk about quenched and precipitation. Same, we are heating up to the same range of temperature and we are holding up to for 30 minutes, then we are quenching in a suitable liquid. Only difference is here. Here we removed it from the furnace and cooled in air. Here we are doing the quenching. Then precipitation is same. We have to again reheat at some temperature. That temperature range is also same. And then we are holding at that particular temperature for 30 minutes and we are cooling it at convenient rate. So this is same. Only difference is here. We are quenching, doing the quenching process here. Here we are doing the normalizing process. So these two processes are used for grade LF787. Now let us look at the chemical composition of ASTM 350. As we know, we are having 7 grades with us: LF1, 2, 3, 5, 6, 9 and 787. So these are the grades which are available in this material standard. If you look at the carbon content, carbon, manganese, phosphorus, sulfur, silicon, nickel, chromium, molybdenum, copper. Okay, so these are the elements which are available in all these grades. So just to have a feel that what is changing here, if you look at the carbon percentage, it is decreasing. Okay, so grade LF787 is having very low carbon. At the same time, LF1 is having 0.3% of the carbon. Similarly, if you look at manganese and phosphorus, these are also changing. Okay, phosphorus is not changing much, but if you see, the LF787 is having very less percentage of phosphorus also. So this is how we can look into the composition, and we can get a feel that there are few grades available in a particular ASTM standard. Based on these compositions, the property of that particular grade will change. So we know what is the function of each and every element. Based on those functions, the percentage will be varying, and the properties will change. So we can always select the grade based on the required properties. Now these are the mechanical properties. Mechanical properties for all the grades. If you see, we have tensile and yield strength listed against each grade. Okay, so we can easily look into any of the grades, and we can say, okay, this grade is stronger as compared to this one. Okay, based on yield strength, more the yield strength, more is the strength available. So we can say, for example, if you take about LF1 and LF2, okay, the tensile strength is within the range of 60 to 85 KSI, whereas in LF2 it is 70 to 95. So we can always say mechanically LF2 is stronger as compared to LF1. So with respect to tensile and yield strength, we can look into the mechanical properties of a particular grade, and based on our requirement, we can choose the specific grade. Now we know that ASTM 350 is for low temperature services, low temperature carbon steel forging fittings. We have to look into the table 3 and 4, which talks about the V notch energy requirements. Okay, we have to perform the Charpai test. For that, we need to fulfill few energy requirement as well as the temperature requirements. If you see, for various grades available within 350, we have the test temperature. Okay, so at these temperature, the test shall be performed. For various grade, it is different, and we have to select the test temperature based on the grade selection. Now, once we know the temperature, we also know that we are going to perform this test on three specimens at least. Set of three specimens will be selected. For that, the Charpy test will be performed, and the average energy absorbed shall be this for particular grade. And for individually, it should be minimum this one. So the for individual also, and for average of three specimen, the energy levels are mentioned in this table. So we have to fulfill these requirements, then only we'll say this material is suitable for impact testing. Now let us look at the hardness requirements. Hardness test, hardness of any particular forged fitting shall not exceed 197 HBW. That also after heat treatment. So HBW means Brinell hardness, W means tungsten carbide. Okay, so this is just to measure this. So 197 is the upper limit after heat treatment. So criteria to measurement is defined in ASTM A961, which is common for all the force fittings. When we talk about hydrostatic test, all the forging metal manufactured under 350 shall be capable of passing hydro test. This is for sure. But this test shall be done only if it is required by the purchaser as a supplementary test S57. If you look at 961, S57 is a supplementary requirement. If it is there in the list from purchaser side, then it has to be performed. Otherwise, we are saying this is all the force fittings are capable of sustaining these temperature, these pressures. Along with this, workmanship, finish, and appearance shall be as per 961. We'll discuss in detail all the requirements which are there in 961. So all these criteria are defined, which are common to most of the standards, are there in 961. In case any of the mechanical test fails, then there are provisions for reheat treatment of that particular forged item, and then we have to retest the same. Okay, any repair which is carried out has to be as per the supplementary requirements which are there in 961 S58. So these requirements we will have to follow. Now if any repair is done, that has to be done through all the welding procedures and qualified welders only. Okay. Also, in accordance with the ASME section 9, all those requirements are met. Again, the repairs done and how those were done and what were the outcomes has to be captured and shared with purchaser. So these are few of the guidelines related to rework and retreatment. Now, if we talk about certification, at the time of procuring the raw material, at the time of manufacturing, and at the time of final product inspection, there will be so many tests which has to be performed. So all these test reports has to be captured by the manufacturer, which will contain all the information related to heat treatment, tensile property results, chemical or product analysis, hardness test result, impact testing result, or any test which was performed during the course of time, that has to be captured and has to be shared in the form of certification. So this is how we can capture the test reports along with the statement which ensures that all the requirements are met. With respect to product marking, there are many guidelines which are there. In addition to the marking requirements of A961, which is there for common guidelines, there are few additional requirements which are specified in ASTM 350. We have to mark QT if it is quenched and tempered, or quenched and precipitated. So this, if it is performed, then QT has to be marked. W has to be marked if it is repaired by welding. Marking shall be painted, stenciled, stamped on a metal or a plastic tag which is securely attached to the fitting, just to add identification for that particular item. Then parts which are meeting all the requirements of more than one class, okay, shall be marked more than one class, such as LF2 CL1 slash CL2. So this is indicating that this particular part will be meeting all the requirement of more than one class. Again, barcoding, if it is specified or required by the purchaser, this has to be done as identification. If used on a small parts, the barcode may be applied to the box or an additionally tag. Okay, so this is something which is supplement requirement. If it is there, that has to be done. So these are few of the things which we really need to take care when we are talking about the marking on a product. Now let us see how we are going to cover ASTM A182. This is a specification for forged or rolled alloy and stainless steel flanges, fittings and valves. And these will be used for high temperature services. So let us see what we are going to cover. We will be discussing in detail what is the scope, exclusions and inclusions, how the ordering information and general requirements are covered, chemical composition, mechanical composition, all the manufacturing and heat treatment requirements, corrosion testing, determinantal phase detection, surface finish, appearance and corrosion detection, intergranule corrosion testing, stabilizing treatment and macro E test, certification and product marking. We will look into each and every header which we have listed here, along with the additional requirement which are covered in somewhere some other ASTM standard. We'll at least come to know which are those ASTM standards where those informations are captured. So let us start with the topic, and we'll start with the scope. We'll cover inclusions and exclusions. So let's start with this topic. Scope and inclusion. Let us see what is covered in ASTM A182. Let's look at the title itself. It covers the forged or rolled alloy and stainless steel pipe, flanges, forged fittings, and valves. Also, these are used for high temperature services. So this is the title which covers most of the scope. We can look into the title and we can understand what is covered and what is not. So in this, we are talking about the low alloy and stainless steels, and this is used for high temperature service. Flanges, fittings, valves, and similar parts which are complying with the dimensional standards are covered in this. The limit is up to 4540 kg. If the weight of specific item increases from 4540 kg, then that is not included. Grades which are included are low alloy steels, ferritic, martensitic, austenitic, and ferritic austenitic stainless steel. So these are all included in this standard. So any uh, valve, flange, or fittings which is made up of this thing, this has included here. Only thing is once which is the weight of any item, if it is increasing than 4540 kg, then we have to refer different specification, maybe A336 and A965, okay, for ferritic and austenitic grades. So this is how the scope is covered in this ASTM A5182. Now, if we talk about ordering information and general requirements, this these two topics are covered in ASTM 961, which covers the general requirements for forged items. So we'll go to that. We'll look into these kind of information, what is available there, and which we can refer here in A182 also. For chemical composition, there is a very big long table. So we have taken a snapshot here, looking at F1, F2, two grades, and the composition itself: carbon, manganese, phosphorus, sulfur, silicon, nickel, chromium. All these elements are there along with the percentage. So we can always refer to these tables to understand what kind of elements are there and what is the chemical properties with respect to that. So we can refer to 182 if we want to check the grade wise composition. There is a table too, we can look into that. Now, if we talk about the manufacturing stages, we know we are talking about alloy and stainless steel. So there is a little difference between these. For alloy, low alloy steels, which are made from open hearth, electric furnace, or basic oxygen process. At the same time, if we talk about stainless steel, electric furnace, vacuum furnace, or by electrostag consumable remelting process. So this is a little difference between these two, and we can say these are the options available for low alloy, and these are the uh, processes which are used for stainless steel. At the same time, there are few points which we need to remember. Flanges of any type, elbows or return bends, tees and header tees shall not be machined directly from the bar stocks. Only cylindrical shaped parts may be machined, that also from hollow bar or forged or rolled solution annealed austenitic stainless steel. Okay, so with these we cannot machine. If we want to machine, only cylindrical shaped parts are there. So this is something which we need to remember with respect to manufacturing process for ASTM 182 grade. When we talk about heat treatment, there are various grades under 182, and we have table 1 where each and everything is very clearly specified. For example, we've taken a small snapshot mentioning a few grades. These are the grades of ASTM A182. Here it is clearly mentioned what type of heat treatment is required. Okay, then the temperature range is also there. Cooling media is also defined. Okay, quenching cooled temperature is also defined. So tempering temperature minimum range is also defined. So this is very nicely detailed table in ASTM A182 where each and every requirement grade wise is specified. So we can always refer to this table when we are talking about heat treatment of particular grade. When we talk about the mechanical properties, that is tensile and hardness requirement, this standard defines clearly each and everything. If we look at table 3 for tensile and hardness requirement, grade wise it is clearly defined: tensile strength, yield strength, hardness. Okay. When we talk about various grades, you can quickly see which one is more stronger. For example, if we talk about 5 and 5A, The tensile strength of 5A is more as compared to F5. So we can always identify that 5A is more stronger as compared to grade F5. So this is how, based on the requirements, we can select the grade based on tensile and mechanical properties. We can always look into these grades and we can select the particular grade based on our requirement. Now, corrosion testing and detrimental phase detection. This is also important when we talk about the various grades. But in case of ASTM A182, corrosion testing is not required. Detrimental phase detection is not required. But let us look into this. If to understand these terms, let us look into intermetallic phase and duplex grade of stainless steel. Intermetallic is nothing but it is a type of metallic alloy that forms a solid state compound between two or metallic elements. Okay, there are few metallic elements within a particular alloy. There is a solid state compound. Okay, when why this kind of solid state compound is there? Because there is a formation of electropositive and electronegative phases within the metal, which are chemically bonded together. Okay, we have few elements, metallic elements in any alloy. These will be having their own chemical bonding with respect to electropositive and electronegative metals. So this kind of phase formation, solid state compound will be there, which is called intermetallic phase. Okay. Now let us talk about duplex grade. This is just a metallurgical structure which contains both austenitic and ferritic in almost equal proportion. Okay, it makes the duplex grade more corrosion resistance and higher strength than 300 series of stainless steel. So we are having both austenitic and ferritic in equal percentage. So those kind of grades will be duplex grades of stainless steel. So why we are discussing these two terms? Now if we, although we don't have to go for this detrimental phase detection, but to understand this test, this detection, a test to detect the losses due to intermetallic and duplex grade of this. Okay. There will be intermetallic phase change in most of the duplex stainless steels. So to detect the losses, there is a test which is called detrimental phase detection. Okay, but as per ASTM A182, these two tests are not required. Corrosion testing is also not required. Detrimental phase detection is also not required. Now, surface finish, appearance, and corrosion protection. Okay, these requirements are there in ASTM 961, which covers all the common requirements for hose fittings, flanges, and valves. So we'll look into that once we go to 961. Now, for intergranular corrosion testing, there are two standards. One is for austenitic stainless steel, another one is ferritic stainless steel. So 262 is there for stainless steel, austenitic stainless steel. 763 is for ferritic one. So these two standards will have to refer if we are going ahead with these kind of testing requirements. Now intergranular corrosion. Let us look into what it is. This is the type of corrosion which generally occurs at grain boundaries. Okay, although we are saying these two standards will have to be referred, but let us try to understand what is intergranular corrosion. Okay, it occurs at grain boundaries. Why it occurs? Due to precipitation of chromium carbide. Okay, now why it occurs? Why chromium carbide is formed? Because the stainless steel becomes very sensitive at elevated temperature, at around 550. If we heat it up to 550, then maybe there is a precipitation of chromium carbide at grain boundaries. So stainless steel with low carbon and stabilized grade are heavily good resistivity against intergranular corrosion. So if we are saying there is a formation of carbon chloride carbides at grain boundaries, if we have lesser percentage of carbon, low carbon content, then this precipitation will be lesser. So these grain boundaries will be safer in low carbon content. So this is how the intergranular corrosion is defined. For any testing or any other requirements, we have to refer these two standards. Now, just to have a brief overview of what is happening for intergranular corrosion testing, when we were talking about austenitic steel and ferritic stainless steels, we are going to refer these two standards, 262 and 763. Now, just have a look what is done there, what is covered there. Okay. One is Strauss test, another is bend test. So both are defined in these standards. For example, in this case, Strauss test, the specimen is boiled in a copper sulfate sulfuric acid mixture for 15 hours. So such requirements will be there. How, what are the tests are there, and what are the uh, activities which we are going to perform during that test. Similarly, for ferritic stainless steel, 763 has to be followed. Here again, various practices are there for tests are defined. How we are going to perform these tests. Most of the time, we are using a few acids, oxalate, ferritic sulfate, copper sulfate, okay, copper. These kind of uh, acids will be there where the specimen will be put into and for particular duration just to check the losses. So these all the tests are defined in these standards. Stabilizing treatment. There are few grades F 321, 321H, 347, 347H, 348, 348H. For these grades, the standard says we have to go for stabilizing treatment. Now, what is this? How we are going to do this? We have to heat the specimen up to this temperature for minimum 4.7 minute per millimeter of thickness, and then we have to cool it. So this is the requirement, and this is how we do it. So this is clearly mentioned. If these grades are used, we have to go for stabilizing treatment. Now, next is macro each test. Okay, this test is to detect or to inspect the cracks, center voids, gaps, pinholes, porosity, etc. How we are going to do is we are going to etch the surface, okay, just to reveal the large scale structures of metallic specimen. Okay, then it is kind of visual inspection, structural, which is visible with unaided eyes. Okay, this test shall be done as per E340 standard test for macro eking metals and alloys. So this is something which is covered in ASTM 182, and we have to follow these clauses with respect to each and every test. So with respect to certification during the raw material or manufacturing stage or at the final product stage, there are few tests which need to be performed. For each and every test, there has to be a report that shall be provided by the manufacturer containing the following minimum information. For example, the heat treatment type, tensile properties, chemical and product analysis results, hardness test results, grain size results, or any other testing requirement which was there as a supplement requirement from purchaser side. So all these test results, test reports has to be captured, and along with the statement that all these tests were performed and these were performed as per the requirements. So this kind of certification will always be there. Now product marking. There are few clauses, few requirements which are mentioned in 182. Along with that, we have to refer 965. But let us look at what is defined here. These are the additional requirements which need to be followed when we are talking about the marking of any product. Quenching and tempered, then QT has to be mentioned. Low alloy or magnetic stainless steel. W is mentioned when there is a repair work, welding repair work. Then this marking can be painted, stenciled, stamped, or on a metal or a plastic tag which need to be attached with the fitting just to identify what kind of fitting it is. Then marking for multiple class, if it is satisfying meeting the requirement of more than one class, then that has to be marked. Again, barcoding, if it is specified by the purchaser that barcoding is required, then this has to be there as an identification mark. General requirement for forgings. ASTM 961 covers all these. So let us see how we are going to cover this section, how we are going to cover the general requirements of A961 ASTM standard. First of all, let us see what are the basic headers. These are the topics which we are going to cover: scope, inclusions, ordering information, manufacturing, heat treatment, impact test requirement, PMI testing, hydrostatic test, heat analysis and product analysis, surface finish, appearance, corrosion protection, certification, marking. So these are the headers which are generally there for all the ASTM standards. Okay, but here same topics are covered, mentioning the general requirement for all these ASTM standards. So let us see how and what is covered in each of the topics. Let's start with the scope and inclusion. First, let us look at the scope and inclusions. What all is covered in this specification, that is forging general requirements. Okay, this is applicable for flanges, forged fittings, valves, and other parts of piping application. So majorly 105, 350, and 182, which are commonly used as a forged material in process industry. This will cover the common requirement for these ASTM standards. Now, along with that, there are other applications where other forging materials are used. For example, A181, forging carbon steel for general purpose piping. 522, forged or rolled nickel alloy steel flanges, fittings, valves, and other parts. So these are few other ASTM standards where forging materials are there, where this standard is applicable also. But in process industry, we are generally using for these three forged materials. This standard, which is talking about the general requirement for forged items, it defines few parameters which need to be prepared or asked by the purchaser while ordering. For example, the quantity, size and pressure class, dimensions, specification numbers with grade or class, supplementary requirements, if any, or any additional requirements from purchaser side. So this is the basic information which has to be there for all the ASTM standards or the items which a purchaser is looking for. Now there are few general requirements with respect to manufacturing of these items. Okay, first of all, the finished part shall be forged only. Okay, all these requirements which are mentioned here, this is if there is any finished part that has to be manufactured from forging. Along with that, flanges, elbow, return bands, these shall not be machined directly from the bar. Okay, only cylindrical parts, that also up to 4 inch only, can be machined directly from the bar. Flanges shall not be directly machined from seamless pipes. Only cylindrical parts can be machined from seamless pipes. So these are few clauses which are there, which are common for all these ASTM standards for forged fittings. Now, with respect to heat treatment, this standard provides common guidelines. For example, it gives definition of annealing, solution annealing, thermal, isothermal annealing, normalizing, tempering, and post-weld heat treatment, and few other heat treatment processes which are there in next slide. So first of all, it defines the terms. Then it defines how we are going to perform these heat treatment processes. For example, for annealing, we have to heat up to certain temperature above transformation range. Then we have to hold it for sufficient time at that particular temperature. Then we have to allow it to cool slowly below transformation range. At the same time, solution annealing. Here, what we are going, we are heating to temperature that causes the chloride, the chromium carbides to go into the solution. Then quenching is done. So we are performing this uh, activity extra here, chromium carbides to go into the solution. That is why we are saying solution annealing. Then it is a normal quenching process. Rapidly cooled means to prevent reprecipitation. Okay, so we want chromium carbide to precipitate and then we quench it so that there is no reprecipitation. So this kind of process is called solution annealing. Then thermal annealing, heating till austenitizing occur in ferrous alloy, then cool and hold at that particular temperature where austenite transforms to the soft ferrite carbon. So this is how these terms are explained. Same is for normalizing, tempering and post weld heat treatment, where the temperature and duration of holding is also defined. So this is how this 961 is establishing the common or general requirements with respect to heat treatment. Similarly, for stress relieving and quenching, it is defined and explained also how we are going to perform this. For example, stress relieving, heating to a stress relieving temperature, then we are holding at that particular temperature for long enough to reduce the stresses, then cooled at a rate that will result into desired results. So this is how these general requirements are defined. First, what are the terms and how we are going to perform it. At the same time, if you talk about impact test requirements, it is defining the temperatures, it is defining the energy absorption levels. So this will be there for low temperature services, but the criteria and the parameters will remain same. Positive material identification. This is really important for not only forged material but for all the materials. Forging materials shall receive positive material identification to ensure that the forging material is of correct chemical composition and material grade. So composition we check here whether that composition is aligned with the material grade composition. So this examination is done to ensure that no mix-up is happened during manufacturing or marking. Okay. So positive marking identification shall be done as per guidelines mentioned in the E1916. So this covers detailed procedure steps, checkpoints, and everything. So that identification test has to be done according to these guidelines. Forging which are not correct of the no, forging materials after PMI identification test, if we find that the correct material grade is not there, then we can always reject it. Okay. Again, the method of forging marking after PMI execution shall be done after agreement between manufacturer and purchaser. So we are done with this test. We establish that the composition is aligned with the grade. Then also we have to establish a method so that we can mark it. How we are going to mark that has to be agreed upon between manufacturer and purchaser. Same is applicable for hydrostatic test also. Hydrostatic test shall be done at a pressure agreed upon between certifying organization and purchaser. Okay. So these are few of the guidelines which are mentioned as a general requirements in A961 with respect to PMI and hydrostatic test. Now, heat analysis and product analysis, these two are really important terms which we really need to understand. Heat analysis is associated with the material which we use as a raw material. We try to check what is the composition or weight percentage of various elements in the raw material, that is ingots or billets. At the same time, the product analysis is the process where we check the composition of end product, okay, which is supplied by the purchaser after manufacturing. So this is before manufacturing, this is after manufacturing. Now, if we are talking about this, on the other hand, if you're buying or supplying a product like a plate, sheet, wire, bar, you would try to conform to the product analysis specification. Okay. So both are important. We need to check the composition for raw material as well as the end product. There are few requirements which are there with respect to surface finish, appearance, and corrosion protection. These are common general requirements which are applicable for most of the forging materials. So first of all, finished part shall be cleaned. Okay, so we have to clean it to remove all the scaling prior to go ahead with surface examination. So cleaning is one thing. Now, once we are saying the cleaning process is there, that should not injure the surface finish. Okay, so cleaning is done in such a way that there is no impact on the surface finish. There is no impact on the material properties. There is no impact on the metallurgical structure. So cleaning is important, but this has to be done very carefully. Now the surface finish will shall allow the detection of imperfection. Okay, but we are going ahead with visual inspection only. So surface finish has surface first we have to clean it so that we can go ahead with the visual inspection. Now we have to ensure that the cleaned part are not recontaminated. So we have to prevent this. Also, the corrosion protective coatings shall be done on exterior or maybe in internal surface of the carbon steel, low and alloy steels. So first we cleaned it, then we ensure that there is no recontamination. Then we are providing a corrosion protective coatings. Okay. For stainless steel and nickel alloy, there is no requirement of coating. But once we are doing this protective coating, we have to ensure that there is no uh, hurdle in doing the welding for socket welds or butt welds or maybe for threaded fitting also. At the same time, we have to ensure that the wall thickness at any point shall not be less than the minimum specified values. So what we are doing, we are cleaning the surface. We are ensuring that this cleaning is not damaging the surface, and then we ensure this is not recontaminated. Then we are providing the coatings to protect the surface from corrosion. These coatings shall not disturb the weldings. Also, the wall thickness will be specified. It should not be less than the specified values. Now, there are basic general requirements with respect to certification and marking also. When we are procuring something from a manufacturer will procure some raw material, then he will manufacture, and then there will be a final product. So there will be so many tests which has to be performed during all these stages. So during these stages, we have to capture these test reports, which will include minimum the product specification number, year and date of issue, result of all the tests which were performed, which are specified in the product specification, and purchase order. So this minimum information will be there. So all those will be in a single document to present the test reports and compliance certificate. So this kind of requirements will have to be fulfilled for all kind of hose fitting. Now for marking, each piece shall be clearly marked with the product specification, grade, class, certified organization, and heat number, service rating. So these are the basic information which has to be there as a marked values. It is not required to mark the product with the specification year and date of issue. Okay, this is not required. This is not a mandatory requirement. Although these are the things which are generally marked, but this is not a mandatory requirement. Also, MSS SP25 is always there, where all these marking requirements, what has to be marked, how it has to be marked, are detailed very nicely. So we have to refer this standard when we are talking about marking for any fitting, flange or valve. Identification tag can also be used for marking where it is not practical due to shape and size. If shape is complicated or small, then maybe identification tag can be associated with that particular item so that we can identify it at site. So these are few of the general requirements with respect to marking and certification. Now let us try to understand various international standards which are available for flanges. Two most important ASME standards are 16.5 and 16.47. 16.5 is a standard which covers flanges and fittings from half inch to 24 inch. This is the size range. If the size is more than 24 inch, that is from 26-inch and higher, then we have to go for 16.47. These are large diameter steel flanges. So these two standards are globally acceptable for all process plants, especially for flanges. We can refer to these two standards. In addition to these, there are few other standards which are relevant to flanges. First one is VS10 flanges. This is the standard for flanges and fittings, which covers plain, integrally cast or forged, and welding weld neck flanges. So this is again a popular standard. Then there are DIN flanges. It is the German National Standardization Organization. DIN standard flanges are metric measurements to measure the valve and flange sizes. Again, there is extension to BS standard, that is EN 1092-1. It is an extension to British standards. It comprises of flange sizes varying from DIN 10 to 4000. Okay, and they are designating in PN 2.5 to PN 400. So this is how the standards are available for process industry, especially related to flanges. Now let us talk about types of flanges. Here, the first topmost type is weld neck flange. Okay, let us see what kind of weld neck flanges are there. Okay, this is actual photo where we can identify the actual weld neck flanges. Now let us look at the configuration. Okay, there is a weld neck, that is why we call it weld neck flange. Okay, this is a high hub flange also we call it because of this hub, and this is tapered, so sometimes we call it tapered hub flange also. Okay, this neck is extended and up to this point where it gets welded with the pipe or with any fitting. Okay, so this weld joint will be there. So this tapered hub provides extra strength. Okay, so that is why we can use this flange in high pressure, high temperature, or maybe in sub-zero applications also. So this is more strong as compared to any other type of flanges. So these can be easily identified with the neck. So once we look into this kind of flanges, we can always say these are weld neck flanges. It is available in both type of facing. If you look at this, this is raised face. It is projected outside this surface, so this is raised face. Also, if it is flat, then we call it flat face surface. So both type of flanges are available, raised face as well as flat face. Now, if we talk about slip-on flanges, okay, slip-on flanges are a kind of ring. If you see, there is a ring with the flange face. This is actual snap of slip-on flanges. Okay, as as the name suggests, this flange slips over the end of pipe or fitting wherever it is connected. This will be slipped over it. If you look at this figure, there is a pipe and this is slipping over the pipe. That means the inside diameter of the flange is always greater than the pipe, so that it gets slipped over the pipe. Also, as we discussed about weld neck flange, there are again raised face and flat face. Both type of slip-on flanges are available. Now there is no neck, there is no tapered hub as we had in weld neck flanges. So the strength of slip-on flange is always lesser than weld neck flanges. These are available in raised face versus flat face, both configurations. But without hub or without weld neck type arrangement, these are weaker. So we generally use these type of flanges for low pressure application and non-critical services. Now let us talk about socket welded flanges. These are the flanges which are having the socket weld type of connection at the end. Okay, so this kind of socket weld connection will be there. The pipe will go inside up to certain point and the welding will be done at the circumferential outside the flange. So there is always extension gap between pipe and the flange surface. This is just to minimize the residual pressure at the weld root that can occur during weld metal solidification. So this gap will always be there in socket welded connection. Now we know this kind of socket welded connections are there only for smaller sizes. So we go for this kind of slip-on socket welded flanges for low pressure services. and for non-critical services. Now, threaded flanges. These are also very much famous in process industry. These are similar to slip-on flanges. If you look at the configuration, this is nearly similar to slip-on flanges. This also slips over the pipe. Only difference is the ID here is equal to the OD of pipe. Okay, so that is not the case in case of slip-on flanges, but here this is the difference. The inside bore of the threaded flange is matched to the inside diameter of the pipe. Okay, so threaded flanges are tapered threads in bore conforming to the ASME 1.20.1. Okay, the main benefit of threaded is that it can be easily installed. Threaded connections are there. This can be easily installed and can be opened. This really gives ease in maintenance. But at the same time, there are chances of leakage, so we generally go for low pressure services only, and for small sizes sometimes we use these kind of flanges in explosive area where welding will develop potential risk. So this is again one of the benefits in case of threaded flanges. We don't go for any kind of welding. So this is one of the benefits here. But we generally use it for low pressure services and non-critical services. There are long neck weld flanges also. Here these are nearly similar to weld neck flanges, but will be having a long neck. Okay, this provides extra reinforcement. That means along with this hub, we are having extra reinforcement so that we can use this kind of flanges in very high pressure services. Okay, these will maybe having square type ends so that it can be used as a nozzle in tanks. Sometimes we call this kind of flanges, which we are calling non long neck flanges, as nozzles also. Okay, so safety purpose in high pressure services, this extra reinforcement is there and can be used for high pressure systems. Now let us talk about lap joint flanges. Here, this is a kind of special flange having stub as a separate part. Okay, if you look at this configuration, this stub is there, flange is there. So stub will be having beveled end welded connection, which can be welded with pipe or fitting, and flange is free. This is not welded with this stub. Okay, so flange remains loose and connected to the mating flange through bolting only. So this bolting connections will be there, but this is not welded here. This is loose. Only internal part, this hub will be, this stub will be welded. Now lap joints are used when the pipe is made of expensive material or in case of dissimilar metals. So this is the important part. When we are having this as expensive material, then we can utilize this kind of lap joint. So this can be of carbon steel, right? Because this is not getting in touch with the fluid. Okay, so connecting carbon steel with the stainless steel, maybe we can utilize this kind of arrangement. This can be stainless steel and this can be carbon steel. So stub is welded to the carbon steel pipe and flange will be bolted to the mating flange. Similarly, in case of metallic to non-metallic connection, we can utilize this kind of lap joints. Okay, but at the same time, lap joints are having less strength than weld neck flange, so it is not preferable in high pressure services. So this is how we can optimize. We are doing nothing but optimizing the cost. Okay, if it is expensive, then we can utilize this kind of arrangement. Blind flange is again one of the types of flanges which are used to blank off the system, whether this is connected at the end of pipe or at nozzle. Again, these will blind off the system. So the main function here of these kind of flanges is to obstruct the flow in the pipe or in the nozzle on the vessel or in the end of pipe for future scope and expansion of the plant. So one is we are obstructing, we are closing the flow, we are obstructing the flow in one direction, or maybe if in future we are planning some connections, then also we can plan this kind of arrangement. So in future, if we want, if we are envisaging additional pump or any future connections, then if it is a flange type, blind flange type, we can always open and we can connect the additional piping system here. So this is how these kind of flanges are used. These flanges are also used to blank off the pipe when we are going ahead with the hydrostatic test, or maybe at the nozzle when pressure vessel is going to check the pressure. So this kind of flanges are blanking off the system. Now reducing flanges. As the name is indicating, these flanges are used to reduce the size from one to another. So these are nearly same as we are aware of reducers. The purpose is same. Only difference is we are having flanges on both ends. Here also, if you look at this, on one side, the larger size is there and the bevel end is there. So pipe can be connected or fitting can be connected here. At the same time, on other side, we have reduced the size. Okay, so these two flanges will be there. But most of the time, when we are having reducers with us, these kind of flanges which we are trying to use to reduce the size are very expensive because there are flanges on both sides. In case of reducers, we will be having butt welded or uh, socket weld type of connections, but these are the flange connections which are always costly. So these are generally not used, not only because of cost, but there is a abrupt change in size also. So these kind of abrupt change can create a kind of turbulence in the system. So these are generally avoided, but in case of exceptions, we can always utilize these kind of flanges. Now we have Weldo flange also, which we sometimes call it Nippo flange. So what we are having here, we are having a weldolet, then a flange, or maybe in between we are having a nipple. Sometimes this nipple is not there, then we call it weldo flange. When nipple is there, we call it nippo flange. So we will be having weldolet at the branch connection. Okay, so this will be touching the outer periphery of the pipe where we are taking this branch, right? So once we are having weldolet at one end, which is connected with the pipe, or you can say header when we're taking a tapping, then this is adding extra reinforcement in the system. So these kind of weldo flanges or nippo flanges are giving us a strong connection, branch connections. Okay, so these are kind of integrated reinforced fitting for 90-degree branch connections, where this will be welded to the periphery of the pipe and this will be connected with the flange. Now, orifice flanges are also very important type of flanges which are available in process industry. We are having tappings from the flange. If you see, this type of tappings will be there. These tapping will be in the form of pairs. One or two pairs of flanges will be there, and these flanges will be having tappings. Most of the time, these are on opposite ends, opposite to each other, both the tappings. But based on requirement, these can be oriented in different angles also. So we are having different type of facing available with these flanges. These may be raised face, ring type, weld neck type. So all those type of arrangements are available. But at the same time, we have to refer ASME B16.36 for the design and dimensions of orifice flanges. Okay, so these kind of arrangements will be there mostly to measure the flow rates in the pipe. So these are generally used to measure flow rates. So this is the basic application. So this is how these flanges are available and used in process industry. Now let us look at the Greylock type flanges. We call it Greylock flange or can be called connectors. If you look at the items which are there, there is a hub, okay, and this is the internal diameter. There is a seal ring which is used to seal the area. Then there is a clamp and there are nut and bolts which are used to tighten the system. So this kind of arrangements will be there. Okay, first the hubs are aligned, they are welded to the pipes on both ends. then the seal is installed in between, then only clamps are there and we tighten it with the bolts. So the simplicity in the design, sealing efficiency and ease in maintenance, the Grello connectors provides wide range of application in petrochemical industry. So the reactor, vessel nozzles, vessel closers, pipe valve ends, and many more locations these can be used. So this kind of arrangement will be there when we are using Grelloc type flanges. Spectacle blinds. These are commonly used item in process industry. If you see the figure 8 is there, it resembles the numerical value 8. So we sometimes we call it figure 8 also. So one section of this spectacle blind is solid, another one is hollow. Okay, so it is installed between two flanges or between valve and flange. It adds additional layer of safety in the system. Once it is uh, solid is visible outside, then that means this is allowing the flow between the piping components. If this portion is visible, then that means this part is obstructing the flow inside the system. Okay, so this is placed like this only, okay, between two flanges. This is a typical arrangement we find in a lot of piping system. So this is very common item which we use in piping systems. Now spades and spacers. These are also utilized, or you can say installed between two flanges. These are similar to spectacle blind. Only difference is in spectacle blind these two items are connected with each other. Here these are separate items. So mostly we go for spades when the size is increased. As the size increases, we cannot use spectacle blind because of its weight. Okay, so we break it into two parts for higher sizes, and the purpose is same. One part is obstructing the flow, another one is allowing the flow. So once the obstruction is required, isolation is required, this portion is used. So these are nothing but similar to spectacle blind only, but because of height, because of weight and size, the items are separated into two parts, spades and spacers. Now let us talk about flange facing. Okay, we have flat face, raised face, lap joint, ring joint, name, male and female, tongue and groove. So let us talk about these facing one by one. So first, let us talk about flat face flanges. Flat face is a kind of face here between two flanges. This face will be flat. Okay, this is a kind of face where we use a gasket which will be having contact with the whole surface. Okay, the whole surface will be contacted with the gasket. So only difference here is for flat face surfaces, the gasket type will be different. Here we have holes in the gaskets also, so that it is in touch. It is compacted between the two flanges. Whole surface is there, but at the same time, flat face flanges are not suitable for very tight kind of arrangements. So we use it where low pressure services are there. For example, low pressure water applications, pump suctions, and mostly water treatment flanges. So flat surfaces are there. It is flat face is one of the type, and preferably gasket between these kind of flanges will be non-metallic gaskets like white tone, EPDM, neoprene. We'll discuss more about gasket in gasket section. Here we are just comparing the we are just trying to understand the flat face type of arrangement on flange face. Now, in case of a raised face flange, this is the face which is there on the flange. This is raised. So, if you see, there is a projection over the surface. The height of this raised face is 1.5 to 1.6 mm up to 300 pound rating, and 6.5 above 300. Okay, these raised face will be having gasket uh, which will be touching up to raised face only. That means gaskets will not have bolts inside. These gaskets will be up to raised face surface only. So it will always be between the flanges, between the bolt dia, and this will provide a very tight and leak proof joint. So diameter and height of the raised face are determined by the pressure rating. So based on pressure rating, the height of raised face will keep on changing. Next is lap joint. Okay, here we have two dissimilar metals. Mostly it is used when the pipe is of expensive material. This flange is not welded to the pipe. This is only connected through bolting with the other flange. So pipe will be having welded connection on one end, whether it is connected with the pipe or fitting, there will be welding connection. And on other end, there will be a flange connection, bolt to bolt. This is not welded anywhere else. Okay, so these kind of flanges will not have that much strength. So only to save some cost for expensive materials, we go for this kind of joints. This is not preferred for high pressure piping. Ring type joint will be having different type of facing. If you see, there will be a ring type facing on the flange. This kind of arrangement is there only when we are going ahead with very high pressure services, high pound rating. Okay, 16.5 and 16.47, they clearly defines the requirement or the design for ring type joint flanges. So the ring type arrangement will be there, which will be available for ring type gasket also. So RTG flange will be having this kind of surface with RTG gaskets in between. Okay, so these are only used for very high pressure services where raised face type of facing is uh, facing may get leaked. So these are very much leak proof type of joints for very high pressure ratings. Male and female type flanges or facing, you can say this is also very much common. Here what we are having, one is projected and one is having groove. So it is nearly similar to tongue and groove type, but only difference is one flange is having a projected facing. Okay, so this is also used for very high pressure services where the female face is 3 by 16-inch deep and the male face is 1 by 4-inch high. Okay, both are smoothly finished. This is very much common. The one is projected, one is having groove. Now another one is tongue and groove. Okay, here again we have a projected surface and another is we are having a groove. Only difference is if you see it is similar to male and female, but here the groove is there instead of flat of surface on one side. We are having a groove. Okay, so this kind of groove on circumferential is there where this tongue part can get fit. So we are saying these kind of flanges are more suitable as compared to male and female as these are self-aligning also. Okay, these type of flanges are commonly used for very high services, especially on pump covers, valve bonnets, shipbuilding, oil fields, offshore natural gas pipe projects. So there is a very good utilization of this kind of arrangement. These are self-aligning and they match the faces of each flange. Okay, to make the joint even more secure, a gasket can also be added between these tongue and groove, which ensures that there is a minimum leakage and it makes a perfect joint. So these are used for very high pressure temperature services. Now let us talk about flange drill details. Okay, these are more related to dimensions which are covered in 16.5 up to 24-inch size and in 16.47 up above 26-inch size. So let us try to understand the basic terms here, which dimensions we are going to refer in these ASME standards. First of all, there is a flange diameter, which is at outer edge to outer edge. Okay. Then pitch circle dia, PCD, that is bolt circle dia. Okay, we can relate it here. This is a dia which we call pitch circle dia. Then there is a raised face. If it is raised face flange, there will be a raised face. So if it is having raised face, then it will be having its own dia also, outer dia of raised face, right? Then raised face height. From this flat surface, there is a projection. That height also is one of the dimensions. Then flange thickness. This is the thickness of the flange, and this is additional projection here. Then hole dia. This is a hole for bolts. The dia of these holes for bolts is hole diameter. This dimension is also important. Then bore. This is bore, which is the inside diameter where the fluid is flowing. So these are basic terms which are related to dimensions, which are related to drilling details, which we need to refer 16.5 and 16.47 for all these dimensions. Flange rating. This is really very important term when we talk about flanges. So let us try to understand what it is and how we refer this. First of all, it is maximum pressure that a flange can withstand at a particular temperature. So it is nothing but a pressure or temperature varying capacity. So it is pressure and temperature combination, and that combination we will be having a maximum pressure which a flange can bear. So that is basic PT rating definition, you can say. With increase in temperature, the capacity or the strength of metal goes down. Okay, so that's why the pressure bearing capacity will also be lesser at higher temperatures. So the combination of pressure and temperature, we decide the maximum pressure which a flange can bear. So 16.5, we have American Society of Mechanical Engineers 16.5 ASME defines the flange ratings. Okay, this is the dimensionless number, and there are 7 flange ratings: 150, 300, 400, 600, 900, 1500, and 2500. So these 7 classes are there. Okay, let us say, let us look at one of the examples of such table which is there in 16.5. If you see, there are temperatures. This is for carbon steel, minus 29 to this thing, and these are the pressures, and these 7 classes are there. So each and every class for this particular temperature range, there is a maximum pressure which this can bear. So let us take any example. For example, let us take this one. For pressure temperature up to 50 degree and up to 19.2 bar pressure, the 150 class is okay. Okay, as we increase the temperature, this pressure bearing capacity keeps on decreasing. With the increase in pressure bearing, if you see at particular temperature, with increase in class, the pressure bearing capacity increases. Okay, so only thing which we were trying to understand here, with increase in temperature, the pressure bearing capacity for a particular class will keep on decreasing. So these are the combinations, these are the material groups which are defined in 16.34 and ASME 31.1 also. So once we know a particular material group, these class rating tables in 16.5 can be referred very easily. For example, if we are talking about material group 1.1, we have forging materials, casting materials, and plate materials. Okay, with respect to that, we can choose the PT rating table from 16.5 very easily. Now let us have a quick look at two different methods with the help of which we can decide the flange rating. Okay, first one is PT rating table, which we just discussed in 16.5. There are tables, ready-made tables, which we can directly refer. Second method is, there is a formula given in 16.5 appendix A, which is useful to calculate the pressure rating. Okay, If we have a particular scenario where we have all these vectors, then we can calculate the pressure class. So these two methods are there. One is ready-made method, ready-made tables are available. Second is there is a formula and we can calculate the pressure class. Let us see what are these parameters which are involved in this uh, formula which is there in appendix A. P1 is always equal to 10 when S1 is expressed in megapascal units and the resultant point will be in bar units. Okay. PR is the pressure rating which we are going to calculate. PT is rated pressure, design pressure you can say. S1 is selected stress value for a particular material at a given temperature. So if we are given a particular situation where the design temperature is mentioned, design pressure is mentioned, material base material is given, and flange material is given. Okay, so we have design temperature, pressure, and the material type. So now we can use these two methods to determine the pressure pipe class, or you can say flange rating. So let us try to use these two parameters and let us use both the methods to calculate the pressure flange rating. So if you look at option 1, we have PT rating table with us. Okay, first of all we need to uh, identify the table itself. How we will identify which table we are going to refer? Okay, first of all we have to refer table 1A of ASME 16.5 to find out PT rating table for ASTM A105. Okay, before that we can identify the material group also. We can see that ASTM A105 flange is in material group 1.1, right? Accordingly, for 1.1 material group, we will select the table 2.1, 2-1.1. Okay. So first, what we are doing, we will go to this table where we'll identify where this carbon steel material for forging is there. Then we'll refer to this table and then we'll go to this table in 16.5. Once we go to this table in 16.5, we can see against 300 temperature where is 50 bar pressure, that is here itself. So here we can say this condition for 50 bar pressure and 300 degree Celsius, the pressure class will be 400. Okay, so we can directly get the class from this table that is given in 16.5. So this is option 1. With respect to pressure temperature conditions, we can classify which class it belongs to. Now let us look at option 2. Option 2, we have a formula which is given in 16.5 appendix A. Here we have C1, S1 and PT. Okay, C1 is 10 standard, S1 allowables, and PT is pressure design pressure which we are taking as an example. So once we put it into this PT we know, so PR can be calculated. So once we put these values in this formula, we'll get 339.14, which is more than 300 class. Hence we can say this belongs to class 400. So these same information we can look into the PT rating table which we just checked in option 1. So both the options are giving us class 400. This is how we can calculate the flange rating of any flange. Also, we need to look at the information which is required from purchaser side and which and the same information has to be ordered. So what we are looking for is the ordering information which purchaser prepares and asked from manufacturer. So let us see what kind of information it is. First of all, we have to mention type of flange which is required, flange rating, okay, dimensional standard, flange facing, contact surface finish, what kind of finish we are looking for, tolerances, how much tolerances are acceptable, which material grade we are looking for, additional material testing requirements, okay, that also we have to mention if applicable, nominal size, wall thickness as defined by schedule, weight or actual decimal walls. So this is the minimum information which has to be there in the purchase order when we are ordering flanges, when we are planning to purchase flanges, so that once this information is available with the manufacturer, they can easily manufacture the flange and supply.